Assalamualaikum and hi everyone. I'm going to continue with the last subtopic for this chapter, which is continuous random variable. For the learning outcomes at the end of the lesson, students should be able to find the probability density function, or in short form, we are using the PDF, and solve the probability from the probability density function. Next, find the cumulative distribution function, which is in short form, we are using the CDF. Solve the probabilities from the cumulative distribution function. And next, find the probability density function from a cumulative distribution function and vice versa. And lastly, compute the expectation and variance of continuous random variable. So I'm going to introduce the continuous random variable. So the probability distribution function, let x be a continuous random variable. It is specified by probability density function. So probability density function for the continuous, it can be represented using the curve. It can be represented by area bounded by the curve of fx above the x-axis. So the total area for the continuous random variable must be equals to 1. Or from here, we can form a properties, which is the integration of fx from the negative infinity to infinity, or the integration of fx from the lowest to the uppermost limit must equals to 1. So you have to clearly understood that is the properties that is the very important properties that you have to be in your mind in order to solve the question involving the continuous random. For the cumulative distribution function, which is another notation for this, which is the CDF, or you can write it as a capital letter. Before this, the probability distribution function, we can use the short form PDF, which is we use the notation of fx. That's the different how we are going to write on the notations. For the CDF of a continuous random variable can be expressed as capital letter of x is equals to probability of x less or equal than 1, x less or equal than x, equals to px less than x, which is equals to integration of fx from negative infinity to x. Okay, this one we are going to find out the probability using the PDF. This is used for finding the probability using the PDF. This is for finding the probability using the CDF. Next two things are different, depends on the questions. And then for the fx is given by the area under the curve from negativity up to x as indicated by the shaded region. So means if we want to find the f of x, it means that we have to integrate from negative infinity up to x with the given function. So the area that we have to find out here is from the negative infinity, or you can replace it to the lowest limit of the given question. So we are going to find the area under the curve up to x. So in a summarize, the probability of the continuous random variable is the area bounded by the curve from the lowest up to the x. Then the fx is the integral of the probability density function. Fx is the derivative of the cumulative distribution function of fx. Okay, these two statements, it means that if you are given the PDF, and you are going to find out the CDF. So from PDF convert to CDF, you need to integrate. In the reverse process, if the question gives you the CDF and you need to find the PDF, from the CDF convert to the PDF, you need to differentiate. It's a reverse process. Okay, then we proceed. For the continuous random variable, we should know that the total area bounded by the function, the total area should be 1. In order to find the median is the value of x, the median is the value of x in which the probability of x less or px less or equal than x should equals to 0.5. Okay, or x can be written as m. M is actually referring to the median. M or x. You can just write it as a f of m or f of x. It's equivalent. So since the total area for the continuous random variable is 1, if you want to find the median it should be in between of the lowest to the uppermost limit. This is the m, so that the probability should be half, should be 0.5. Or you can use this diagram, so it means that the area under the curve should be 0.5. So what's the value of m here? So in order to find out the median, it should be written as f of m equals to 0.5. If you are using the CDF, or if you are using the PDF, you need to integrate from negative infinity up to m for the function fx, which is PDF, or you can write it in this form. This is just notation. So how you are going to find out the median, whether using the PDF or CDF. If you are using the PDF, you need to integrate. If you are using the CDF, you need to substitute into the CDF function that you have found out, or you are already given in the question. Okay, let's go to the summarize comparison between probability density function, which is the PDF, and the CDF for the continuous random variable. Okay, so for the first part, to show that it is a PDF. So when the question asks to show that it is the PDF, you have to remember the properties. By taking the properties of the continuous random variable, you need to integrate for the function PDF. This is the PDF from the lowest limit up until the uppermost limit, depends on the question, right? And then next, to find the unknown constant. To find out the unknown constant for the PDF, this is the PDF, this is the CDF. For the PDF, you have to integrate from the lowest to the uppermost limit and equate to 1. But for the CDF, when the question asks to find a constant, using the CDF function, you don't have to integrate because you already given the integrated function. You need to substitute a value. Okay, to substitute that value, it must depends on the questions. It must depends on what interval. Okay, and then we are going to compare the substitution of that x from the left side and from the right side. Okay, we are going to compare these two values in order to find that constant. Okay, and then continue of finding the probability. If the question asks to find the probability of x less than a or x less or equal than a, it's equivalent. In continuous random variable, these two things are equivalent since px equal then a equals to 0 for the continuous random variable. For the probability of x equals to a is equals to 0, because when it's exactly equals to a, it doesn't give you any error. Okay, since continuous is referring to area bounded, it should be in the range. So when the question asks to find the x equals to a, it should be equals to 0. So from that statements, probability for x less than a, it should equivalent to px less or equal than a, because the px equals to a give you 0. So how to find the probability using the PDF? So when using the PDF, you need to integrate from the lowest limit up to the probability that the question asks for. Okay, why? For the CDF function, you just need to substitute. The given value into the CDF functions, right? And then continue with, if the question asks for the greater, than a, greater or equal, you have to remember that for the continuous random variable, it doesn't matter whether it has the equal sign or doesn't have the equal sign, it will be the same. For the PDF function, you just need to integrate from a until the uppermost limit, a until infinity, from the value that the question asks for up to the uppermost limit. Why? For the CDF, we won't directly substitute into the function of CDF. We need to do some rearrangement for the function. Okay, so means that here, if the question asks for the x greater than a, it's equals to 1 minus px less than a. So for the px less than a, it is equals to f of a. That's why for the greater sign, for the sign of inequalities which is greater, it should be 1 minus f of a. And then continue with the next comparison. If the question asks for the in between a and b, whether it doesn't matter whether it has the equal sign or doesn't have the equal sign. Okay, for the PDF, you need to integrate from a until b. Why? For the CDF, you have to minus for the f of b minus f of a. Means you have to substitute the upper limit minus with the lower limit for the range of the question asked for. So if the question asks for from A until B, so you have to minus FB minus with FA. And then go for the median. So for the median, when are using the PDF, you have to integrate from negative infinity up to m in order to get the 0.5. So that m is your median. For the CDF, you just need to substitute the m into the correct function of your CDF and equate to 0. And the rest is just solve the equations. Okay, and then continue with the mean and expectation. The expectation is just using the PDF. It doesn't have for the CDF. So you just remember that when it comes to finding the means, expectation or variance, you need to use the PDF, integration of PDF. So what's the difference between expected and variance? To find the expected of x, you have to multiply x with the fx. Before you integrate, you have to multiply with x before you integrate. After you multiply x with fx, and then you just integrate with the limit lowest to the uppermost limit. Okay, for the variance, formula for the variance, it should be expected of x squared minus expected of x bracket squared. So to find out expected of x squared, it should be x squared multiplied with the PDF function fx with the limit lowest to the uppermost limit. So that's all before we go for the example.
Example 5. Let the function of a continuous random variable x be defined by function x squared over 18 from negative 3 until 3 and 0 elsewhere. A. Show that the function is the probability density function. To show that the function is the probability density function, we need to integrate from negative infinity until infinity for the function must be equal to 1. So in order to do that, I draw the number line first and I put up the values of x, which is negative 3 and 3. The function varied from negative 3 until 3 so it's situated here, and then 0 as well. So we know that from the number line, the far left here refer to the value negative infinity, whereas the far right here refer to the value infinity. So what we're going to do is we are going to integrate from negative infinity until negative 3, but the function is 0. And then add up with integrate negative infinity 3 until 3. The function is x squared over 18. And then 3 until infinity, the function is 0. So we know that integrating 0 function will give us the value of 0, and here will be x cubed to the power over 54. Substitute 3 and negative 3, integrate 0 must be equal to 0, and then substitute the value of 3 inside x, and then negative 3 inside x, and we're going to end up with 1. So we managed to show that the function is the probability density function. For any continuous random variable, we need to know that probability x less than equal to 2 is exactly equal to probability x less than equal to 2, which means that for continuous random variable, the equal sign doesn't matter. So in order to find the probability x less than 2, I'm going to put 2 into the number line, so it's going to be situated around here. So we're going to find the probability x less than 2, which means starting from negative infinity until 2. So we clearly see that we need to separate it into two parts. For the first part, we need to integrate from here negative infinity until negative 3, but the function is 0, and then add up with integrate negative 3 until 2, but from negative 3 until 2, the function is x squared over 18. And then just integrate it, integrate 0 will be equal to 0, integrate this one will be x cubed over 54, and then substitute 2 and negative 3 into the function will give us the value of 35 over 54. The second one, to find the probability x greater than 0, we need to integrate. I will put up 0 into the number line, so it's going to be situated around there, and then we're going to find the probability x greater than 0, which means to the right of 0. So we need to separate it into 2. For the first one, for the first part, we're going to be integrate from 0 to 3, but the function is x squared over 18. And then for the second part, integrate from 3 until here, infinity, but the function is 0. Integrate it. Integrate 0, 0. Substitute the value. It's going to be half. And then find the probability from negative 2 until 2. Put negative 2 into the number line, and also 2. And then we're going to find the probability from negative 2 until 2. So to find the probability, we just need to integrate from negative 2 until 2. And the function is x squared over 18. Integrate it as usual, and then substitute the values of x. Going to get 8 over 27. Sketch the graph of the function. Since the function is y equal to x squared over 18, so this is just the quadratic function. Fx x, here the function is fx. and then it's just the quadratic function as square over 18. Let's see, it may looks like this, and then it only varied from -3 until 3. So if we find the value of y here, it's going to be half. Next, the question asks us to find the mode. So mode or x equal to -3 and x equal to 3, since they have the highest probability, which is half here.
Now we are going to proceed with the example 6. A continuous random variable x has a probability density function, which is PDF, short form is PDF, as fx equals to kx cubed for the x varies from 0 until 4. For the part A, the question asks to find the value of k. So how we are going to get this value of k? So of course, we need to apply the properties for the continuous random variable, which is the integration from the lowest to the uppermost limit must equals to 1. So we are going to equate the integration for this function equals to 1. So then what we need to do is, of course, we are going to integrate. The only function here is kx cubed. So we have kx cubed dx from the lowest limit, which is 0, the uppermost limit is 4, and then we equate to 1. So we're going to solve it. So since we have k as a coefficient, we can take out the k. So we are going to integrate x cubed dx from 0 until 4 equals to 1. So integrate x cubed will give you x power 4 over 4 with the k outside here, and the limit from 0 until 4 equals to 1. So then we are going to substitute the limit, which is 4 power of 4 over 4 minus 0 equals to 1. That will give you, inside the bracket, will give you 64. So then you get 64 of k equals to 1. So then k will give you 1 over 64. Okay, that one for the part A. So we go for the part B. Right, so for part B, the question asks to find the expected of x and expected of x squared. So we should know that to find the expected of x is equals to integration of x multiplied with the fx from the lowest to the uppermost limit. Why? To find the expected of x squared, it should be integration of x squared multiplied with the fx dx from the lowest to the uppermost limit. So things that need to be highlighted here is, for the expected of x, we need to multiply x. Okay, just remember that we need to multiply x with the fx before we find out the integrations. And for the expected of x squared, we have to multiply x squared with the function of fx. We need to simplify it first and then we integrate. Okay, so continue for the question. Example 6 for B. Okay, we are going to find out the expected of x. So expected of x is equals to integration of the lowest limit. So the lowest limit for this example is 0 and the uppermost limit is 4. So we're going to integrate from 0 until 4. And then we have to multiply x since we are finding the expected of x. Okay, just remember x. Right, multiply with the function fx. Okay, the function fx given is, we're going to write down here, fx is kx cubed. Then we have to find out the value of k, which is 1 over 64 x cubed. So we're going to substitute here x multiplied with 1 over 64 of x cubed dx. Okay, before we integrate, we are going to expand this x with another x, which is x cubed. And since we have 1 over 64 here, I will take out the 1 over 64. So 1 over 64 integrate with x power of 4. Okay, since x power of 1 multiply with x power of 3 will give you x power 4. Okay, don't forget the limit, which is from 0 until 4. And then we are going to integrate the x power 4. So integrate the x power 4 will give you x power 5 over 5. Okay, with 1 over 64 outside here. And the limit is from 0 until 4. Okay, so just substitute 4 power of 5 over 5 minus 0. So then, as a final answer, we will get 16 over 5 for the expected of x. Okay, and then we proceed with the expected of x squared. So to find the expected of x squared, we have to integrate, okay, from the lowest limit, which is 0, and the uppermost limit, which is 4. And we have to remember that we have to multiply with x squared with the given function, which is 1 over 64 of x cubed tx. Okay, just remember x squared when we have to find out the expected of x squared. Right, so we're going to simplify. X squared multiply with x cubed. And we have 1 over 64, so I will just take out the 1 over 64 outside here. Alright, so x squared multiply with x cubed will give you x power 5 with the limit 0 until 4 dx. So we're going to integrate the x power 5, which is, it will give you x power 6 over 6. Okay, the limits 0 until 4, 1 over 64 outside here. And then substitute. So we are going to have 4 power of 6 over 6 minus 0 with 1 over 64. And then you just calculate. So at the end, you will get 32 over 3. Okay, we have done for the expected of x and expected of x squared. We are going to proceed with part C. So part C, the question asks to find the variance. So the formula for finding the variance is expected of x squared minus of expected of x bracket square. So you should have the square outside here. Okay, so since we have find out the value of expected of square and also expected of x from the previous part, which is from B, so we are just going to substitute into the formula. So the variance of x is equals to expected of x square is if you go back, the expected of x is 16 over 5 and 32. So here should be 32 over 3 minus 16 over 5, since we have the square outside here. So we have to square this one. And then calculate. So at the end, you will get 32 over 75. Okay, next for D. For D, question, start with the words hence. Okay, we're going to start with the hence, evaluate the given questions. So means that for this part, all the given questions need to be used, whatever we have calculated from the previous part. So if we go through all the questions, so you have to find out the expected and the variance with different value. So how are we going to evaluate all those questions? So of course we are going to use the properties for the expected and the variance. So we go for the expected, the first part, which is expected of x plus 5. So we are going to use the properties. So the properties here is the suitable properties here is for the expected of ax plus b. State that if we have this kind of expected is equals to a of expected of x plus b. So we are going to use these properties. Right, so we are going to rewrite this one equals to expected of x plus 5 by applying these properties. So expected of x from the part B, we have expected of x is 16 over 5, and then you just plus with 5 and then calculate. So we got 41 over 5. Right, for the second Roman, applying the same properties. Okay, we are going to use the same properties, which is expected of 10 minus x will equals to 10 minus expected of x. So 10 minus expected of x equals to 10 minus 16 over 5, which is equals to 34 over 5. Alright, so then next expected for 3x squared minus 5. So we are going to use this kind of properties. If we have expected of ax squared plus bx plus c, so will equals to a expected of x squared plus b expected of x plus c. Okay, so we are going to rewrite this one, become 3 expected of x squared minus 5. So then we are going to substitute expected of x squared. So expected of x squared from the part B, we already calculated, which is 32 over 3. So minus with 5. So you just calculate at the end, this one can be cancelled out. So 32 minus 5 will give you 27. Alright, we go for next part. Okay, this one for the variance. Okay, if we have to find out the variance for x plus 5, we're going to use the properties, which is variance for x plus 5 equals to variance of x plus with 0, because variance constant is equals to 0. So variance of x, we already calculated from the part C, which is, we already calculated, which is 32 over 27. We're going to substitute, just substitute here, which is 32 over 75. Right, and then lastly, we have to find out the variance for 10 minus 3x. Okay, applying the properties. By applying the properties, we equals to 0 minus 0 plus with, sorry, I'm going to erase this. Okay, equals to 0 plus with negative 3 squared of variance x. Okay, just be careful on this part, especially when involving negative. It should be negative square. It's supposed not to be negative 3 square. It's supposed to be plus with negative 3 square multiply with the variance. So negative 3 square is equals to 9 multiply with the variance, which is 32 over 75. So we will get the final answer is 96 over 25. Right, so we have done for the example 6.